the analysis of current flow. Going to analyze this WASSCE question 2017. It says a circuit is set up as shown in the diagram above. When the key is closed, the ammeter reading will be, so this is the ammeter here, a device used for measuring current, and on top here is the key, and here is our cell. So as it is now, current doesn't flow from the cell. There's no current drawn because the key is open. So when the key is closed, current begins to flow. Remember, this side is the positive, this side is the negative. Conventionally, it flows from the positive. So it will flow down and flow through the ammeter, and the ammeter will take the reading. Then when it reaches this point where we have two resistors connected in parallel, the current will divide into two based on the value of the resistances. In this case, since they are the same value, the current will divide equally. Then at this point, the current will rejoin again into one value, that's their summation. So we'll flow here and return back to the negative side. So that is how current flow. So what the ammeter will see here is the current drawn from the battery. That's the total current drawn from the cell. That's what the ammeter will see. So how are we going to analyze this? Now, from Ohm's law, we have that voltage equals to what? Current times resistance. So current here will represent our equivalent current, that's the total current from the cell. R here will be what? The equivalent resistance, where V here will be the voltage of the cell. So that is how then we make I here the subject. I equivalent will be what? V divided by what? R equivalent. So how do we find R equivalent? Already we know our V to be 3.0 volts, which is the same thing as 3 volts. And then, okay, so now our R equivalent, our equivalent resistance, analyzing that these two resistors are in parallel. Then this combined together, as they are in parallel, combined together, they are in series with this other resistor here. Remember, the current divided into two and then joined back to become one. So we are going to, the total resistance here will be this parallel equivalence of this parallel connection, which will then be in series with this other one. So this will be equivalent of this in parallel plus this one here. So R equivalent to, let me start with 1 here, or let me start with this one, 1 times 1 divided by 1 plus 1. When you have two resistors that are in parallel, you can do it as R1, R2 over R1 plus R2. That's if there are two resistors. If there are not two resistors, you begin to do 1 over R1 equals to 1 over R2, like that, plus that. So here is this time this that we analyze this parallel, then plus the 1 here, 1. So this will be equals to 1 times 1 divided by 2 plus 1. So LCM is 2, that will give you 3 over 2 ohms. So our equivalent resistance is what? Is 3 over 2 ohms. 3 over 2 ohms. Or you can say 1.5 ohms. So we are not looking for resistance, we are looking for current. So our current will now be, which is voltage divided by the equivalent resistance. Our voltage is 3 divided by equivalent resistance, which is 3 over 2. If you analyze this well, you end up having 3 times 2 over 3. So that 3 will cancel 3. You are now left with 2 amps. So the ammeter reading, the current the ammeter will read will be 2 amps. Option C. If you have any question, you can ask in the comment section. Thank you.